Oasis privacy layer, and then we're going to see a demo. Time permitting, I wanted to do some live coding for you, but since my laptop is a little weird, I'm going to show you how the code works, and we'll just walk through it rather than actually watching me code it up. Hopefully you'll get the idea. All right, without further ado, let us begin. All right, so the Oasis network is the basis of Oasis privacy layer. I mean, that's why it's called Oasis privacy layer. It's based on Oasis. So Oasis is a layer 1 scalability architecture that's unique in that it can provide trusted execution environments to smart contracts. And what this does is it gives privacy to the code running in the code and the state that is in your contract. So it does this using trusted execution environments. So you can think of a trusted execution environment as a locked box inside of, like, you have a computer, it's in a locked room, and it has armed security guards outside the door. Not even the owner of the computer can see what's going on inside. So in fact, what this is a special chip, essentially, inside of your processor that encrypts everything going into and out of the processor, and also provides the ability to tell the rest of the world using a cryptographic attestation that this is a very genuine trusted execution environment and that the software inside is correctly loaded and all that good stuff. All right, so we use trusted execution environments to enable the Oasis privacy layer. We'll get into that. But I want to let you know that as you build on the Oasis, we have this huge grants program, big ecosystem, lots of different developers, so there's a lot of interoperability you can use. And that's one of the benefits of using trusted execution environments is that all these different apps can just port directly without too much difficulty. You don't have to learn new programming languages, you just use Solidity and Hardhat, and it's all super fun. So what we're going to offer you, so once you're on the layer 1 Oasis Sapphire, you get all these nice things like high TPS scalability, but mainly privacy. Like, that's what we're trying to offer you here today. So now we have that building block, which is the Oasis Sapphire layer 1, and we're going to then turn that into a layer 2. So we're going to be providing privacy to your layer 1 dApps with minimal changes to your code. So this is going to be useful for things like DAOs. And so you have secret ballot. You're going to see that in just a bit. DID, things like keeping secrets on-chain, proving identity data, and then having that be interoperable on-chain. So like Web3 DID without the whole off-chain asynchronous component. And then gaming, things like randomized games of chance, like where you have like critical hits, rewards, lotteries, and then things like fog of war. And you can just easily code that up in Solidity by just saying like, require a person has like access, like can view, and then if they do, they can return the data. So it's a very convenient way to add privacy to your games and build like Web 2 games in Web 3. And of course, DeFi. So I like to say like MEV resistant DeFi, you can't front run or sandwich what you can't see. So that's like one of those things that you can do if you have privacy. All right, so again, the benefits of Oasis privacy layer that the private variables are actually private, and you can use them for your layer 1 dApp. You can use the exact same tooling that you've been using for Ethereum, like Hardhat, MetaMask, Solidity, Viper, everything you already know and love, and all the many, many hours of developer experience put into that. And you get, of course, low fees, cool things like RNG for your games, encryption for like end-to-end encryption, and then it's just completely easy to use. So there's really no reason not to use it, except if you're if you already have a layer 1 dApp and it has tons of users and tons of TVL, and you just want to add privacy without moving people over. All right, so now let's bring in the privacy layer. So the privacy layer is essentially you keep your dApp on your layer 1, and then on the Oasis side, you have the rest of your contract doing the secret part. So you can think of, if you're familiar with hardware enclaves like Intel SGX, that gives the untrusted host app this little confidential piece. The Oasis privacy layer is like an enclave for Web3. It's like an enclave for dApps. So you can put the private state of your application on the Oasis side and use the Oasis privacy layer to bridge back and forth to give your dApp privacy without ever moving your dApp. And you can get started in this in under 15 minutes because, of course, it's super easy to use. It's just Solidity and EVM and all that nice things. So here's a diagram of how it works. So on the left side you have the user, and that's just your standard Web3 user. Now they're going to not even know that Oasis even exists. So like what we're going for is that there's no change to the user experience. And we do that using a message passing bridge, which you see on the right, and a gas relayer. So what happens, the flow of a transaction is the user will submit some transaction on the home chain, which I call it Ethereum, and interact with your layer 1 Ethereum dApp. Now they want to submit some things privately to the private side of your entire dApp, right? So what the user is going to do is pay using the gas tokens on that layer 1 chain, so they don't even need to have the Oasis gas token, and then submit their transaction through the gas relayer. Like MetaMask is just going to pop up like one little box, say sign message. Not even sign transaction, just sign message. And then they're going to hit sign, not change networks, just sign, and that will get submitted through the gas relayer to Sapphire, Oasis Sapphire, where it will then process it with end-to-end confidentiality. And then at some time later, when you want the results back on your layer 1 dApp, Sapphire will send a message back over this message passing bridge to your layer 1 dApp, where you can do things like unlock tokens, create contracts, or modify settings of the DAO, doing a contract upgrade maybe. So that's the basic idea of the Oasis privacy layer. And this is in diagrammatic form. If you want to take a photo, you can. You can ask me about it too. So Oasis Privacy Layer and Oasis Sapphire are on mainnet today. You can use them right now. I mean, I'm going to show you on testnet because I don't like paying money for stuff, but like if you want to use it on mainnet, you can. Just like bring your dApp today. So over here we have the more links, and then we also have the links to the Oasis Privacy Layer. So I recommend that if you're interested, you scan all of these QR codes. And in a couple of weeks, we're going to be doing a Privacy for Web3 hackathon where you can win super nice prizes for building on the Oasis privacy layer. So if you ask me, it's actually pretty easy to get started. And if you build a cool dApp, then you can make some good prizes, get a head start on the ecosystem fund, get some grants. Should be pretty fun. Bring home glory for your team. All right, so now I'm going to move over to the demo part. Like that was all very abstract, but you got to get the idea. I'm going to pause really quick for questions before we get into the demo. Yeah. Sorry, one sec.
Is it that essentially you need two contracts then, one for the app and then one specifically just to handle your privacy on the other one?
Yeah, I mean, you have two contracts. The one contract is on your layer 1, and then you make a second contract on Oasis Sapphire that implements the privacy part of the app. Good question. Thanks. Anyone, any other questions before we get into the demo? All right, the crowd is going wild for the demo. Let's do it now. All right. All right, so here we have the secret ballot demo. So what we're going to see in this secret ballot demo is a DAO that's on Binance Smart Chain testnet, and the ballot box is going to be on Oasis Sapphire. So what's going to happen is the votes are going to be collected privately on Oasis Sapphire using the Oasis privacy layer, and then only after voting has completed will the final result be sent back to Binance Smart Chain testnet. The votes will not be revealed. But in actually this case they will, because like let's say you want transparency for after voting has been done. So what you're trying to avoid here is mainly the first mover advantage, like when the first person to votes, then everyone else follows. So voting will be made public after this poll has been completed. And like that's just like actually 3 lines of code difference, so you don't have to like think too hard. You just like write solidity. This is like a literally require statement, like is voting done? Like if yes, then return the actual vote. So you can program literally whatever you can think of into these things. Like the privacy is fully up to you as the developer. Okay. So this is a live demo. If you actually head to this, you could vote too if you could somehow figure out how to get the voting token. But anyway, let's just begin. So we're going to figure out which winter sport is the best. And because we're in Denver and we want to, I mean, it's like a hot topic. So the first thing we're going to do is push the vote weight. So what this means is I have my DAO voting token on Binance Smart Chain testnet, and I need to tell the Sapphire side how to, like that I can vote. So what's going to happen here is I'm going to send a message over the message passing bridge to Oasis Sapphire. Push vote weight. And then I'll be able to vote. So this is actually going to go away pretty soon because we have this new zero knowledge bridge that will just allow you to push this data directly. It's like read only. There's no reason to submit a transaction. That's just how it is. All right. So what's happening right now is the transaction's been submitted to Binance Smart Chain testnet to push the vote weight over. This is going to invoke the message passing bridge. We're going to see the results over here on the Sapphire side as a log very shortly. All right, so well, if it didn't revert, I promise this was working just a second ago. Could be the internet being not so great. Because like it looks right here that it actually succeeded, so I'm not really sure what it's going on about. Yeah, I don't get it. This looks like perfectly okay. Yeah, see, look, it's working. This thing's just like gaslighting me. All right, so right now we're waiting for the bridge to do its thing. The message passing bridge we're using right now using the Seller bridge, but we also have the ability to support other bridges like multi-chain, the Anycall interface, the wormhole one, and also the Chainlink bridge. All right, so the vote await has been pushed. We'll see how that looks. So the transaction has popped up on the DAO side. All right, and now we're going to vote. So I need to switch network to Sapphire really quick just because like this, my wallet's a little buggy. But you won't actually have to do this because of the gas relay. You can just submit the transaction directly through the to Oasis Sapphire because it's submitting to the gas relay. All right, so I'm just going to vote. And so the choices are skiing, snowboarding, and neither. I prefer the beach. And because I came here from Miami and I'm not interested in this cold weather, I say neither. But you may have different opinions. That's okay. All right, so I'm going to submit this transaction now to the Sapphire testnet. So it's going to be sending, and we should see the transaction pop up over here. Okay, great. So the voting has completed. Now what's going to happen, the voting has actually closed because the termination conditions have been met. Like I'm voting with a huge amount of quorum. So what's going to happen now is that the message is going to go back over the bridge saying this vote has been closed. Please record the final result. The actual vote has not been revealed. So I want to show to you that the data is actually completely private. So over here we have the transaction that we just submitted to Sapphire. This was the voting transaction, so let's look into it. So the beauty of Oasis Sapphire is that we're just doing like this trickery so that we pack encrypted data into the transaction field so that the MetaMask and stuff continue to work. They don't actually look at this data field. So I'm going to go into CyberChef and decode what's in this transaction. So normally when you're submitting Solidity transaction, it's just like ABI encoded data. So in this case, it's actually this CBOR struct that's been packed into the data field, and it contains the encrypted data. The public key, so that we can do Diffie-Hellman key exchange, so it's end-to-end encrypted, and then the actual encrypted data as well as the nonce for security. Okay, so that's how you can see that the data on Sapphire is end-to-end encrypted and how you get confidentiality. All right, so the bridge has finished its action and it's come back, and you can see on the logs that the bridge has sent back the event. Unfortunately, the internet sucks. Whatever, I'll get back to that. Anyway, so that we can see when we go back to the main page, ignoring this, that very shortly the polls will line up, and we'll see that the poll has been executed and that we'll have our ballot back on the DAO contract. So here we are. Which winter sport is the best? And the outcome is I prefer the beach. Sorry, guys. All right, so here's what the bridge does. So it's coming from the bridge, and then you have that option 2 was the winner. So that was the beach option. All right, so that's like basically how it works. Pretty cool. Well, I mean, if you ask me, but like maybe I built it, so of course I like it. All right, so once again, I'll pause for questions because like maybe I lost some people, but otherwise we'll like go into some of the code on GitHub and see how you can integrate it into your dApp. All right. So I had actually intended to like code up a dApp for you like live, but my computer is too weird, so I can't do that. So I'll again walk you through what's going on here. Okay. So the back end is super clean for this secret ballot demo. The front end is a pile of garbage because I'm not a front end coder, but like the back end's super nice. All right, so check out what's going on. So we have the ballot box. That's the Sapphire side contract, and the DAO. That's the BSC testnet side contract. All right, so here's the way that the Oasis privacy layer works. So you simply import the Oasis privacy layer from our Oasis privacy layer contract, and then you say contract DAO is host. This is the host application, so you can consider enclave host. This is the host. And all you have to do to set this up is in the constructor, pass in the address of the enclave side contract on Sapphire, and then call this method called register endpoint. So it takes a string, that's the name of the endpoint, and a callback function. So it's just like JavaScript. So this one in particular is the ballot close callback, and it's going to be executed to like record the results of the poll, right? So over here we have opal ballot close. This is an internal function, and all it does is decode the arguments. The library itself checks the security, the sender, and makes sure all like the context is correct. But then all you have to do is decode the arguments and like basically do the thing. So the only extra lines that you're doing due to like the Oasis privacy layer are like this function, the definition, the decoding, and returning the result. So like 3 extra lines of code. All right, so now let's look at the other side. On the other side, we have the ballot box, and it's going to be basically the same thing. So the interface between these two is this post message interface. We're going to be posting messages back and forth. So again, we register our endpoints, and these are coming from the host, and the host is going to be doing post message. So the ballot closed. If you recall, when I was executing the ballot, I voted. The ballot has reached determination conditions, so it closes. So if the Sapphire side is going to post a message called ballot close back over the bridge to the host side. So all you need to do is this extra 1 line of code saying ballot closed, and then you ABI encode the arguments, and then it sends it over. So again, another like 3 lines of code to add confidentiality to your dApp. Pretty nice. So what you're not seeing here is like all of the checking, the network switching, and like gas relayer context stuff, all done by the library. So it has like first-class support for gas relaying, first-class support for like ERC2771 context. And also, if you want to run this locally, you just need to put in this thing called auto switch. So you do auto switch BSC. So if you deploy locally, it does use like a local bridge. If you deploy to a test net, it uses the test and Sapphire test net. If you deploy to mainnet, then it uses the mainnet. So it's actually super convenient for developers to use. All right. So that's like basically the Oasis privacy layer in a nutshell. And then in terms of like just getting this into your dApp, it's just, you just need to figure out how to split your dApp into like the public part and the private part. And that's just the hardest part. And like the syntax for it is super easy, so you just need to think about how it's done. And of course, we also have these, the hackathons, the docs, and the grants program, so we can very gladly assist you getting these things done because we really want Web3 users to have privacy. Like, it's a fundamental right. And that's what we're trying to make happen through the convenience of the Oasis privacy layer. Cool. Thank you for watching, everyone. I hope that you enjoyed the presentation. And if you have any questions, you can ask now, or you can come up to me after. And, I mean, everything is good. Yeah. Sorry. So the question was, do you pay the fees on Oasis when you send the private? Yeah, so the user pays using the gas relay. So if you're familiar with the ETH gas station network, you approve some ERC20 tokens. The gas relayer will then send the transaction using their own Rose token to Sapphire and then deduct some balance on like the mainnet side. So basically, users don't even need to know that Sapphire exists. They just need to approve the gas relayer. Yeah, it's like really annoying getting these gas tokens. So like we're definitely trying to make it so you don't have to like KYC, go to your exchange. Like, nah, that's way too inconvenient. Yeah, good question. Yeah.
Do you take some basis points, or how do you keep the lights on?
Oasis takes absolutely nothing, so this is a completely free service. I mean, like you're paying gas to the validators, but otherwise, no.
Okay.
The gas relayer might take a little bit, but you can run your own gas relayer. It's like no big deal. Like Oasis actually offers one. It's subsidized, so any transaction going into and out of Sapphire, there's just completely at cost. Yeah, we don't make any money.
Thanks.
Thanks. Cool. Thank you everyone so much. Really appreciate you coming to watch this.